Okay, here we go. Problem 1. Let me get this over. Problem 1. So, it's asking us to find the value of this multiplication minus this multiplication. This one's pretty straightforward. We can literally just multiply it out. So, 9901 times 101 is equal to 1, 0, 10 carry the 1, 10 carry the 1, 10 carry the 1, 10 carry the 1, carry the 1. And then 99 times 10101, this is just 999999. You can figure that out. And if we subtract these, that's the right number of ones of zeros, I hope. If we subtract these, we find that the answer is 2. If you really did not know how to multiply, you could also look at the last digits and narrow it down to these two answer choices. But that gives us that our answer is A, 2. On to problem 2. Let us go down. A model used to estimate the time it will take blah 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 blah. So we have that the time is equal to t. The A and B are what we're trying to find basically. A and B are some numbers. L is the length of the trail, and G is the altitude gain. So it says it'll take 69 minutes if it's this much long and this high, and also if it's this much long and this high. So we can substitute 69 into time, and the length and gain for the first trail, which is 1.5 miles, and length is multiplied by A, so 1.5A, and 800 gain, so 800B. And this also equals 1.2 miles plus 1100 feet, so 1100B. And now we can just take this equation and solve for B in terms of A. That way we can plug it back in and find what A and B are. So now we have that this is if we subtract this to the other side, 0.3a equals 300b, or a equals 1000b. And now we can substitute this back into here to get 69 equals 1500b if we plug in 1000b in for a, plus 800b, or 69 equals 2300b, or b is equal to 300. Whoops, that's not correct. 100b is equal to 3. Okay, so now what we're trying to find, what the problem asked us to find in the first place, was how long it'll take if it's 4.2 miles, so that's going to be 4.2a plus 4,000 feet, so 4,000b. What does this equal? Well, we found earlier that a is 1,000b, so it's 4,200b plus 4,000b, which equals 8,200b. But remember, 100b is equal to 3, which is 82 times 3, which is going to be 246. So our answer is B. Onto problem 3. Let me see if I can get this. All right, I'm going to get this down here. Okay. Problem 3. What is the sum of the digits of the smallest prime that can be written as a sum of 5 distinct primes? So, 5 distinct primes. Let's just try to find the smallest number that can be written as a sum of 5 distinct primes, right? So we're going to take the 5 smallest prime numbers, which are 2, 3, 5, 7, and 11. And when we add these together, we get, let's see, 10, 21, 28. Is that right? Yeah. 28 clearly doesn't work. That's not prime. So, let's try to make this a little bit bigger. 30. You'll notice something's wrong because these are all even numbers. We cannot have 2 as one of our primes because 2 is the only even prime, right? So that means that if we add the 4 other numbers together, we have to add 4 odd numbers together, which is going to be an even sum, which means our sum will always be even, which means that we have to use the 5 smallest primes that are not including 2. Let's try 3, 5, 7, 11, 13. What does this add up to? Let's see. This is 8, 15, 26, 39. 39 is still not prime. It's divisible by 3 and 13. But if we try the next one, the next smallest one, which is just going to be going to the next prime, what does this equal? This is 43. 43 is prime. So that means we're done. Our answer is just the sum of the digits of this, which is 7. All right. Next problem. The number 2024 is written as the sum of not necessarily distinct two-digit numbers. What is the least number of two-digit numbers needed to write this sum? So what we're going to do is we're going to try to use the biggest two-digit numbers as possible, because the bigger numbers we use, the fewer of them we have to use. So the biggest two-digit number is 99, right? Let's just try using like 20 of them right now. This is 1980. And then we can see that, so that means that no, if we add together 20 two-digit numbers, it's always going to be at most 1980, which means we're guaranteed to have to use a 21st one. So now we can just add 44, and this will give us 2024. So that means that we use 20 99s and 124. Let's say 24 times 1 for consistency. And this gave us 2024. So that means our answer has to be 21 numbers, the 2099s plus the 124. Okay. Problem 5. What is the least value of n such that n factorial is a multiple of 2024? So 2024, okay, I'm going to scroll down a bit. So 2024, this is a useful fact to know. 2024 is equal to 2 cubed times 11 times 23, or 8 times 11 times 23. Since 23 is a prime number, 22 factorial cannot be a multiple of 23, since there's no 23 less than equal to 22. And 23 factorial is obviously going to have 8, 11, and 23 as factors, because it multiplies. That's how factorials work. So that means our answer is 23. On to problem 6. This problem is a little bit tricky to prove that it's the right answer, but you can get a pretty good idea. So what we're going to do, the question is asking what is the minimum number of successive swaps of adjacent letters for us to reverse the string, basically. So what we gotta do is the F has to get to the beginning somehow. So we're going to switch these two first, and we're going to get A, B, C, D, F, E. And now we're going to keep bringing the F to the beginning. A, B, C, D, A, B, C, F, D, E, sorry. And so on, until the F's at the beginning. And how many steps did this take? Well, 1 to move it to the 5th spot, 2 to move it to the 4th spot, 3, 4, 5. It would take 5 steps total. And now we need to move the E to the 2nd spot. So it would go F, A, B, C, E, D after we switch the E and the D. And then we have the E in the 2nd spot. This takes 4. And so on. To move the D to the 3rd spot, we'll need 3. To move the C to the 2nd spot, or to the 4th spot, we'll need 2. And to move the B into the 5th spot, we'll need 1 more swap. And then the A will be in the last spot. And this is a total of 5 plus 4 plus 3 plus 2 plus 1 is 15 swaps. If you want to prove this is the minimum, it'll take a little more work. You can look at the number of pairs that need to be swapped. But I'm not going to go into that. Problem 7 is a bit of an annoying one. So first, oh wow, my computer is slow. The problem is asking us to find 3 integers that multiply to 60, and they have to add up to a positive number, and we're trying to find the minimum possible value of that. So obviously we're going to want to use 2 negative numbers and 1 positive number, because that's probably going to be better than just using 3 positive numbers. So that means we're going to take three numbers, A, B, and C. Let's say C is the biggest one of them. C has to be the positive number because if C were the negative number, then if we added C were a negative number, then if we add them up, we would get a negative number. So that means we have a negative number, and a positive number that multiply to 60. So let's just say that A is the smaller one out of A and B because C is the biggest number, or A and B are the same. It doesn't matter. We'll say the smallest. Let's say A is less than or equal to B and C. So then let's say A is 1, right? Then we have 1 in 60, 2 in 30, 3 in 10. You get the point. 4 in 15. Oh, 3 in 20. 4 in 15, 5 in 12, 6 in 10, right? And A and B are negative, so we're going to put a negative in front of all of these. And now we're just going to add these up and see which ones work. Clearly, -1, -6, and 10 is the best option right here. This gives us a sum 3. And then, now we can try to set A equals -2. Now we need the other two to be 30. So, B has to be at least -2, or it has to be at least 2. And then this would end up being 15, and so on. You get the point. Essentially, what we're doing here is we're just listing all of them out. I think you can bash through it on your own. The answer is going to be 3. This is our best option. On to problem 8. A, B, C, and D. Let's just call them A, B, C, and D because it's easier that way. They work in a chocolate factory. A, B, and C started working at 10 p.m. and they can pack this many packages every 3 minutes. Later, D joins them and they can pack 5 every 4 minutes. And they packed 450. So first of all, let's find out the total amount of time they worked for, right? So 2:45 p.m. minus 1 p.m. is 105 minutes. So how many packages did A, B, and C pack during this time? They can pack 4 plus 3 plus 3 equals 10 packages every 3 minutes. And now 105 is equal to 3 times 35. That equals 350 packages. So that means that A, B, and C together packed 350 packages. So that means D on her own had to pack 100 packages. But D packs 5 packages every 4 minutes. That means that D worked for 80 minutes. And now we can just figure out where D started, because we know D ended at 2:45 p.m. If we subtract 80 minutes, that's going to be 1:25 p.m. is our answer. Problem 9 is also a little tricky. Please stop. Please stop. Thank you. All right. So, problem 9. In how many ways can 6 juniors and 6 seniors form 3 distinct teams of 4 people so that each team has 2 juniors and 2 seniors? So, what we're just going to do is we're going to form 3 groups of 2 in the 6 juniors, 3 groups of 2 in the 2 seniors, and then multiply by 6, because that's the total number of ways where we can rearrange these to form 3 groups of 4, because we can match this one with any of these 3, and then this one with one of the other ones, and so on. So how many ways are there to form 3 groups of 2? Well, for the first group of 2, there's 6 choose 2 ways to choose the 2 people in this first group. And then, since we've already chosen 2 people, there's only going to be 4 choose 2 ways to choose the other 2 people for this group. The last group is just 0, is just 1 way. Those are the 2 remaining people. However, you could note that every triplet of groups is counted 6 times. That's 3 factorial, because we could have done these 3 groups in any order. So we have to divide by 3 factorial. What does this equal? It equals 15. The number is same for this. It's the exact same. So we have 15 times 6, which equals 15 times 90, or 1350. Oh, I can scroll like this. Okay, that's a lot easier. Sorry. Alright. Problem 10. Consider the following operation. Given a positive integer n, if n is a multiple of 3, then we divide it by 3. Otherwise, we add 10. So that means we divide by 3 if we can, otherwise we add 10. So it's asking if we start with 100, what do we get after 100 applications? 100 we can't divide by 3, so we just go to 110. We still can't divide by 3, so we go to 120. Now we can, so we go to 40 and 50, because we have to keep adding 10. And now we have 60, which means we can divide. We have to keep adding. Whoops. Now we can divide again. And now you'll note that when we add 10 to 10, we get 20 again, which means now we're stuck in a loop. So if we apply it once, we get here 2 times, 3 times, 4 times, 5 times. So if we apply it 6 times, we get to 20. If we apply it 7 times, we get to 30. If we apply it 8 times, we get to 10. And now we'll see that if we apply it 9 times, we're back to 20. If we apply it 10 times, we're back to 30. If we apply it 11 times, we're back to 10. And that just means that if we apply it 99 times, then we'll be at 20. Because that's just because we're in a loop now. Any multiple of 3 number of times is going to give us 20. So that means that on our 100th try, we're going to be on 30, which is our answer. Okay. Problem 11. This problem's a bit of a doozy. So first things first, let's just square both sides. It's just asking how many m and n, where m and n are both integers, not necessarily positive, just integers, such that this is true. Let's just square both sides, and remember, since a square root is always, since this is the positive square root, m has to be greater than or equal to 0. So let's not forget this. Now let's just subtract. N squared minus m squared equals 49. Let's factor this because we know everything has to be an integer. Now we can factor this. This has to be either 1 and 49, 7 and 7, 49 and 1, or the negatives of all of those. And now we can just see which of these give us solutions. We can solve this system of equations where n plus m equals 1 and n minus m equals 49. This one gives us that n is equal to 25, m is equal to 24, or negative 24. And this doesn't work since m has to be greater than or equal to 0. So this is bad. This gives us n equals 7, m equals 0. So this is good. This gives us n is 25, m is 24, which is good. This gives us n is negative 25, m is 24, which is good. This gives us n is negative 7, m is 0, which is good. This gives us n is negative 25, m is negative 24, which is no good. If we count these, 1, 2, 3, 4. There are 4 pairs. Cool. On to problem 12. I know a lot of people that messed up problem 12 because they didn't read the problem quite carefully. I probably would have too, but I didn't. Thankfully. It's a Legend of Zelda reference. So the key thing about this problem is that these are not the daily changes in score. These are daily changes in score compared to the last day. So that means that on August the 2nd, we are currently at 80 points above August 1st. Minus 90 means we are at minus 90 compared to August 2nd. So that means that we're a net of minus 10 compared to August 1st. If we minus another 10, that means we're at minus 20 compared to August 1st. And now we're at plus 40 compared to August 1st. And now we're at 0 compared to August 1st. So now we can just average all these together. On August 1st, obviously, we're 0 compared to August 1st. So we're just going to take our original score, which is our baseline, 1700 plus 0 plus 80 minus 10 minus 20 plus 40 plus 0 over 6. What we're doing here is we're essentially just taking we're just taking this 1700 out from on top of here because all of these, because on August 1st we had 1700 plus 0, on August 1st we had 1700 plus 80, then we had 1700 minus 10, and so on. And we took out the 6 times 1700 from the top and moved it over here to make this easier to calculate. If we add this up, we get 1715. All right, cool. Oh my gosh, if only I could use a mouse. All right, so this is a problem about transformations. So commuting means we can do them in either order and we'll get the same thing all the time. So let's call this one transformation 1, which is a translation 2 units to the right. We'll call this one transformation 2, which is a 90-degree rotation clockwise about the origin. We'll call this one transformation 3, a reflection across the x-axis. And we'll call this one transformation 4, which is a dilation centered at the origin with scale factor 2, which basically means we just stretch it away 2 times away from the origin. It's asking how many of pairs of these commute. So let's just list them out, right? So we have 1 and 2, we have 1 and 3, we have 1 and 4, we have 2 and 3, we have 2 and 4, and we have 3 and 4. That might be too far. All right. So one and two, this is a translation to the right and a rotation around the origin. This obviously doesn't commute because if we rotate it 90 degrees about the origin and then we move right, that's not the same as if we first move right and then rotate about the origin. Let's just take like 1, 0, for example. If we move right first and then rotate, we'll end up somewhere here. But if we rotate first and then move to the right, we'll end up somewhere here. So that clearly doesn't work. For 1 and 3, a translation 2 units to the right and then reflection over the x-axis, this clearly works because moving directly to the right has nothing to do with reflecting over the x-axis. 1 and 4, moving to the right and scaling obviously doesn't work, right? Because if we move to the right 2 times and then we scale, if we move to the right first and then scale, then our movement to the right is also going to get scaled. So that doesn't work. A rotation and a reflection, does this work? This does not work. Once again, let's just consider like this point, right? Let's just take an example. If we rotate first and then reflect, we'll end up here. But if we reflect first and then rotate, we'll end up here. So this doesn't work. 2 and 4, a rotation and a dilation. If you think about it, right, it doesn't really the dilation doesn't change how far rotated we are, and the rotation doesn't change how far away from the origin we are. So this should work. And then for 3 and 4, same thing. A reflection doesn't change how far away from the origin we are, and a dilation doesn't change which side of the x-axis we're on. So this also works. So that means our final answer is 3, because 3 of these work. Problem 14 has is stated in a bit of a messy way, but we can figure it out. One side of an equilateral triangle of height 24 lies on line L. So let's just draw that triangle right now. So that's the triangle. The height is 24. This is line L. So this is L. The height is 24. So let's draw that. A circle of radius 12 is tangent to line L and tangent to the circle. Externally tangent to the circle. Since the radius is 12, the height of the circle is also 24. That is a terrible circle. Probably because the triangle is terrible. I can't draw on a drawing tablet. I'm sorry. Okay, that's a little better. Let's just pretend this is tangent. The area of the region exterior to the triangle and circle and bounded by the 3 things, so that would be this area right here, can be written as that. So we're just trying to find the area of this. Let's say this is the center of the circle, right? And since these are tangent, these are perpendicular, these are radii. And now we can find, let's split this area into 3 parts. So what we're going to do is we're going to find the area of this kite right here, and then subtract the area of the part of the circle that's inside the kite to get us this final area in here. So to find the area of this kite, we can just take this right triangle and double it. So it turns out that this right triangle is a 30, 60, 90, because since this is equilateral, we have 60 degrees here. So that would mean that this remaining bit is 120 degrees, but since these two angles are congruent, they have to both be 60 degrees. And since we have 60 degrees in a right angle, this is 30, 60, 90. And now we can use the ratio to find that this is 12 divided by root 3, or 4 root 3. So now the area of the whole trapezoid is just 1/2. Well, we have 2 right triangles, so we're going to double it. 1/2 base times height. And this is just equal to 48 root 3. But now we have to subtract the portion of the circle. But we can see that since these two are both 30 degrees, this big angle right here is 60 degrees. So that means that the area of the part of the circle is going to be 1/6 of the whole area of the circle. And since the radius is 12, we're going to take pi r squared divided by 6. This is going to equal, what, 24 pi? So that means our final answer is 48 root 3 minus 24 pi. And if we take a plus b plus c, that's going to be 75. Okay, cool. Problem 15. Oh my gosh. Please scroll properly. All right. Problem 15. Let m be the greatest integer such that both of these are perfect squares. What's the units digit of m? So what we're going to do is we're going to find the difference between these two numbers, because that's what dictates how big m can be. So the difference between these two numbers is 3773 minus 1213 equals 2560. So these two numbers, we want them in terms of if we list out the squares, we want them to be as close together as possible, because that'll mean that m is as big as possible, because the bigger the numbers are, the farther away squares are. But perfect squares always differ by an odd number, and 2560 is not odd. So that means these cannot be consecutive perfect squares. Instead, let's try to have one perfect square between them. Then we can rewrite 2560 as 1279 plus 1281. And now we can see that if we take 639 squared plus 1279, this is equal to 639 squared plus 2 times 639 plus 1. This is just 639 plus 1 squared equals 640 squared. And now if we add 1281, we get 641 squared. So that means that our two numbers are 639 squared and 641 squared. Since we just want the units digit, we know that this has units digit 1. So that means that m has to have units digit 11 minus 3 equals 8, because 8 plus 3 will end in 1. So our answer is 8. I think this is the first E in the test. No, that is not the first E in the test. What am I saying? There's a bunch of E's before that. Are there? Yeah, there are definitely E's before that. All right, next problem. So this problem is very big, but the most important thing to know is that these numbers represent the areas of the rectangles, and all of the rectangles are similar. So the first thing we want to do is find the area of the big rectangle. So that's just going to be adding all these numbers up. I find it very helpful to just circle the numbers as you add them so that you can be sure that you don't add incorrectly. But what you'll find is that the area of the whole rectangle is 200. So now we're trying to find AB. So let's just let AB be x, okay? Then the other side of the rectangle has to be 200 over x, because the area is 200. So this is 200 over x. However, we can also see that This is the long side of this side is equal to the long side of this rectangle with area 36 plus the short side of this rectangle with area 32. The long side of this rectangle with area 36 is going to be x times the square root of 36 over 200. And the area and the length of the short side of the rectangle with side length 32 is going to be 200 over x times root 32 over 200. And this just follows because of similarity ratios, right? If we, for example, if we double the side length, we quadruple the area. And now we can just set this equal to 200 over x because that's the side length of the whole big other side. And now we can just solve this for x. There's going to be let's multiply through by x and 200. X squared times what? Square root of 36. Let's just multiply by root 200, right? 200 root 32 equals 200 root 200. Then x squared times 30 times 6 equals, what is this? 800 root 2. This is equal to 2000 root 2. So x squared times 6 is equal to 1200 root 2. Or x squared is 200 root 2, which is also 100 root 8. So x is equal to 10 times the fourth root of 8. That's our answer. On to problem 17. Two teams are in a best. I don't remember this problem. Oh yeah, two teams are in the best 2 out of 3 playoff. The teams will play at most 3 games, and the winner of the playoff is the first team to win 2 games. So they're going to play 3 games. So this one's at A's home field, and then the other 2 are at B's home field. Team A has a 2/3 chance of winning at home, and a P chance of winning away. And they're independent. The probability that Team A wins the playoff is 1/2, and then we're trying to find P. So what are the ways in which Team A can win the playoff? A can win the first 2 games and then just be done. A can win the first game and the third game and be done, or A can win the last 2 games, and B would have to win the first game. So let's just do all of those. So if A wins the first 2 games, this has probability 2/3 P. If A wins the first game, loses the second game, and wins the third game, this has probability 2/3 times 1 minus P times P. If B wins the first game and A wins the second 2 games, then this has probability 1/3 P squared. So now what we've been given is that these add up to 1/2. So this is 2/3 P plus 2/3 1 minus PP plus 1/3 P squared equals 1/2. And now let's just multiply, let's expand this a bit and we can just solve this quadratic. 2/3 P minus 2/3 P squared plus 1/3 P squared equals 1/2. Let's multiply through by 6 in order to get rid of the fractions. So this is going to be 8P minus 2P squared equals 3. 2P squared minus 8P plus 3 equals 0. So P, now we can use the quadratic formula, equals 8 plus or minus the square root of 64 minus 24 is 40 divided by 2, or divided by 2 times 2, which is 4. And this is equal to 1/2 times 4 minus the square root of 10. Because it can't be plus because probabilities have to be between 0 and 1. And now, if we look back at the question, we're looking for m plus n, which is going to be 4 plus 10, which is 14, because it was 1/2 root 4, or 4 minus root 10. Problem 18. There are exactly k positive integers from 5 to 2024 such that the base b integer this is divisible by 16. What is the sum of the digits of k? So the easiest thing we can do right now is just to convert 2024 base b into base 10. So that's going to be 2b cubed plus 2b plus 4. And we have to have this be divisible by 16. So that means that b cubed plus b plus 2 has to be divisible by 8. So now let's just make a table of values of b that are okay. So if b is 0 mod 8, or 1 mod 8, or 2, or 3, or 4, or 5, or 6, or 7, then we want to see if this has to be equal to 0. This has to be congruent to 0 mod 8. So if we plug in 0, we get 2. If we plug in 1, we get 1 plus 1 plus 2 is 4. If we plug in 2, we get 0 plus 2 plus 2 is 4. If we plug in 3, we get 27, which is 3 plus 2, which is 0. So 3 is working. If we plug in 4, we get 0 plus 4 plus 2 is 6. If we plug in 5, we get 125, which is equal to 5, plus 5, which is 10, which is going to be 2, plus 2 is 4, so that's not working. If we plug in 6, we get, what is 6 cubed? That's 216. Oh, 6 is, yeah, that's 0 because it's even. Plus 6 plus 2, which is working. And if we plug in 7, we get negative 1 plus 7 plus 2, which is 0, which is also working. So that means that b has to either be congruent to 3, 6, or 7 mod 8. So how many 2024 is going to be divisible by 8, I think. It's 8 times 11 times 23, as we said earlier. It's 8 times 253. So that means that we have 3, 6, 7, and then 1 times 3, 6, and 7, and then 1 times 8 plus 3, 6, and 7, and then 2 times 8 plus 3, 6, and 7, all the way till 252 times 8 plus 3, 6, and 7. So that means we have 253 times 3 equals 759. However, we have to make sure we don't include the original 3 because 3 is less than 5. So our final answer is 758, which is going to be a digit sum of 20. MA is a little evil. If you don't remember to remove the 3, you would have gotten this answer choice, which is wrong. Next problem. Oh, this problem is a little evil. A, 720, and B are in a geometric sequence where B is the biggest one, and we're trying to find the smallest possible value for what that could be. So this problem is really mean. So we need A and B to be integers. So let's just find the prime factorization of 720 real quick. It's going to be 2 times 3 times 5 is going to be, if we divide out a 30, that's going to become 24. So we need to multiply by 8 and by 3. It's 2 to the 4th times 3 squared times 5. And what this means is that we need to multiply this by some fraction, right? Our common ratio is going to be some fraction. We need some factor of 720 on the bottom and some other factor of 720 on the top. And this is kind of hand wavy, but if you kind of just experiment, you'll find that 16 over 15 works very well. I'm not really sure how quite to rigorously do this, but if you just play around with it, you'll find that this equals 768, and this seems very close. And it is also an answer choice. 7 plus 6 plus 8 is 21. This problem I had to kind of guess on. I'm still not quite sure on like a very reliable way to do this problem other than to just like guess and check and see how close you can get or see how small you can get. Problem 20. So this is essentially just saying we're picking some numbers from 1 to 2024 such that they're at least 3 apart, and if they're odd numbers, then they're at least 7 apart. So let's just try to be greedy here. It's called a greedy algorithm. So we're going to start with 1, right? And then the numbers have to be at least 3 apart. So our next number is 4. And then after that, our next number is 7. But we're not allowed to have 7, since odd numbers have to be at least 7 apart, and 1 and 7 are not 7 apart. So let's use 8 instead. And now our next number is 11. And now our next number is 14, because we keep adding 3. And then, once again, we can't have 17, since 11 and 17 are too close together. So we'll go 18, and then 21, and so on. And what you'll notice is that we're just getting the numbers with last digit 1, 4, and 8. How many of those are there? 3 times 202. But 2028 is not in there, so we have to subtract 1. So our answer is 605. What? Oh, 3 times 203. I'm a little ridiculous. 608. Problem 21 is not a good problem. It's creative, it's not fun. I think a lot of people have opinions about the test quality of this test. So essentially what's going on here is that all of these numbers are integers. All of these dots represent numbers, right? And all of these numbers are integers, and every row and column is an arithmetic sequence. And we're trying to find this question mark right here. So this problem, the reason I don't really like this problem is because my solution was literally just you say this number is x and this number is y. And since we start at 0, this is simple to have an arithmetic progression. This has to be 2x, this has to be 3x, this has to be 4x. This has to be 2y, this has to be 3y, this has to be 4y. And now we can say, I don't know, find this number in terms of both x and y. In terms of x, it's going to be 2x over 3 plus 16 because x and 48 are 3 apart, so we have to have minus x over 3 plus 16. And on the other hand, it's also the average of it's also y plus 16 over 2. So we just set these equal to each other. And then we can also find, I don't know, this number in terms of both x and y. That is going to equal 2x plus 6. And it's also going to equal what? 32 minus y, because we have y, and then minus y plus 16, minus y plus 16. So now we can just solve this system of equations. And it's a big mess, but what we eventually get is that x equals, I think it was 4, and y equals 10. I'm just going to solve it. I think y equals 20. Yeah, x equals 3 and y equals 20 if you solve these equations. You get x equals 3 and y equals 20. So now we can just find all of the numbers. So this number is going to be 60 and 48, so this is 36. This number is going to be 24. And since this number is 9 and this is 24, we have to go 14, 19, 24, and our answer is 29. It's a bashy problem. It's annoying. 22 is not much better. Excuse me. This is problem 22. So this is a lot of 30, 60, 90 triangles, right? So we have that this long edge right here is going to be the root 3 edge. And how we're going to do this is we're just going to use base time 1/2 base times height. So you'll notice that the base is equal to 4 of these lengths all joined together. So we just need to find this length in order to find the base. Thankfully, this is a right angle. Oops. Oh my freaking gosh. Okay. Sorry, I'm not experienced with this. Okay, so if this is root 3 and this is a right angle, then we also know this angle. This angle is just going to be this angle, which is two 30 degrees angles joined together. So this angle is 30 degrees, which means we have a 30, 60, 90 right triangle. Oh wait, sorry, 60 degrees. This is 60 degrees, so we have a 30, 60, 90 right triangle. So that means that this is going to be root 3, this is going to be 3 halves, because it's going to be root 3 divided by, or root 3 times root 3 over 2, which is going to be 3 halves. So that means AB equals 6. For the height, we have that at the height is going to equal this length, which is root 3, plus this length. And this is just going to be root 3 over 2 because of the same 30, 60, 90 triangle. So that means our height is going to be root 3 plus root 3 over 2, which is equal to 3 root 3 over 2. hopefully we know how to find area of a triangle. It's going to be 9 root 3 over 2, which is this one. Problem 23 was one of the better problems. I still didn't like it though. Problem 23. A, B, and C are integers, and they satisfy these equations, and we're trying to find AB plus BC plus CA. So a natural thing to do might be to add the equations together, but this actually doesn't help us at all. Because now we're just left with an A plus B plus C that we can't deal with. Or something. I don't know what this number is. So let's not do that. Instead, let's try only adding together 2 of the equations, because there's not really anything else we can do. So if we add together 2 of the equations, we get, let's say we add together the first 2 equations, right? AB plus BC plus A plus C equals 187. Ooh, that's convenient. We can factor out a B times A plus C plus A plus C. And this is equal to B plus 1 times A plus C. And we can add together the other equations too. So if we add together the first and third equations, we're going to get A plus 1 times B plus C is equal to 160. And then the last 2 equations together are going to give us C plus 1 times A plus B equals 147. So these two, obviously the numbers can't be too big, right? So it wouldn't make sense for this to be 1 times 187. So it has to be 11 times 17 or negative 11 times negative 17. 160 has a lot of different ways to factor, so let's just leave that alone for now. And 147 is 3 times 49, but this seems pretty far away. So let's use the other one instead. We'll use 21 times 7. Or negative 21 times negative 7. So now we can just bash through these and see if we get something that works. So let's let B plus 1 equal, let's say, 11 first, right? Then B is 10, and A plus C has to be negative 17. If B is 10, and C... Okay, so I'm not going to go through it because I'm tired and my voice hurts, but essentially we can just go through all of the different possibilities for B, and then eventually we'll find that B plus 1 equals negative 11, and A plus C equals negative 17 is going to work. Because this will give us C plus 1 times A minus 12, because B is going to be negative 12, equals 21 times, negative 21 times negative 7. And A is going to end up being negative 9, and C is negative 8 in this case. And then if we plug this into the second equation, we're going to see that it works, because we have negative 8 times negative 8 minus 12, which is going to be negative 8 times negative 20, which is 160. So that means our final answer is A equals negative 9, B equals negative 12, C equals negative 8. And if we find AB plus BC plus CA, it's going to equal D, 276. I think it does at least. I remember it does. Ooh, 24 is, I think, not too bad to explain. A bee is moving in a 3-dimensional space, and basically, this is a really weird way to word. Just imagine we start at the origin, and then we randomly choose which way we want to go. There's 6 ways we can go: left, right, up, down, forward, backward. So at each step, we just randomly choose which way we go. So it doesn't really matter where we go on the first step, because all 6 directions are the same, symmetrically. So let's just say we go in this direction once. Now, if we go back, then we're dead, because we have to travel 4 distinct edges of a unit cube. If we go this way, then we're also dead, because now we can't make a unit cube. So that means that we have to go in some perpendicular direction to this. And there's 4 of those. So that means we have a 4/6 chance of not being dead after the first 2 moves. So let's say we moved this way, where like this is X, this is Y, and Z is up this way or something. So that means that we're definitely going to, that means that this square is definitely going to be, I'm going to use a different color. That means that this square is definitely going to be part of our cube. So now there's two different cubes we can trace. We can either trace this cube that goes above, or we can trace the cube where it goes below. Either way, our next step, we are either going to go up or down, or we're going to go left. Let's say we go up or down, right? If we go up or down, we have a 2/6 chance of doing that. If we go up or down, now we are restricted to only one cube because we chose either the up cube or the down cube to go on. So now you can see that there's only two ways left for us to go. So if we went up or down, then we have two ways to go. But if we went back, which has a 1/6 chance of happening, whoops, that's not what I meant to do. If we went back this way on the third step, then we can still either choose the up or down cube, as well as go this way. So that means we have three ways to go. If we multiply these together, this is 2/27, I think. And this is 1/18. And now adding everything up together, this is 4/54. 3/54 gives us 7/54 is our final answer. Problem 25, which many have called the one saving grace of this test because the quality was very questionable. But 25 was a nice question. Nice problem. So problem 25. This is a puzzle called Slitherlink. You can go look it up if you want, but it's a puzzle called Slitherlink. Essentially, we have to draw some loop that doesn't intersect itself around these on this grid, such that all of these squares with one on them have exactly one edge that is on the loop. So considering all of these at the same time is a little messy. So let's just think about the very left one. So let's say we have this as part of the loop. Let's say this edge is part of the loop, right? Then if we go down, we're dead, since this one is going to have two edges. So that means it has to go up on this side, since the loop has to continue. And the loop has to continue, and the loop has to continue, and the loop has to continue. And what you'll find is that this is going to be the only way if this is part of the edge. Similarly, if the bottom edge of this left square is part of the loop, then we have to use this loop. So that is going to give us two. That is going to give us two possible loops. Now, let's think about what happens if this left edge is part of the loop. Once again, we can't go like this because we're going to be dead. So that means we have to go up all the way to the top here and down all the way to the bottom here. And the loop has to continue, so we have to go like these. And now let's think about the second one. Okay, let's consider the one on the right, right? Okay, how am I going to explain this? Let's consider the second one. The second one cannot have this left one be part of the loop, because that would kill the one on the left. It cannot have this right one be part of the loop, right? Because then this would have to go up. Because if we go left or right, then it kills one of the ones. Same thing here, it has to go down. But now, everything over here is inaccessible. All of these ones are going to die, because they're all going to have 0. So that means that we can't have the one on the right as well. That means we need to have either the top or the bottom. If this top part is part of the loop, then we can't go here, because now we're going to kill either one of the ones. So that means that this bottom loop will have to extend this way. And this top loop has to come down to meet the one. And similarly, if we choose the bottom here, then this has to extend here and this way. So that means that we have two choices for where to put this one. And now, we still have two choices. We can either have up or down for this one. And we can still have two choices. Let's say we keep choosing down. And then we still have two choices. Let's say we chose to go like this. And so on, all the way until right here. Let's say we went like this. I don't know. Right? And now this one can either be like this or or one of these two. The reason we're allowed to have this now is because no ones are going to die if we do this, because this one is already satisfied. So we have one case where it's like this. We have one case where it's like this, and one case where it's like this, and one case where it's like this. So that means we're going to have 3 multiplied by 2 choices for each one of these 5, which is going to be 2 to the 5. And this is going to equal 96. Now we can do the same thing, except we set the left side to be inside by 1 like this. And what you'll notice is that this is just going to be almost the same thing, except we have 1 fewer choice because we don't get to choose this one anymore. We only get to choose these 4 being up or down. So that's going to be 3 times 2 to the 4, which is going to be 48. So now we add 2 plus 96 plus 48 equals 146 is our final answer. And that concludes the test. The final answers are A, B, 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 D, D, B, A, B, C, D, E, C, D, E, D, E, D, E, C, and C, B, D, B, C. All right, the end.